Now we are starting with trigonometry, and this is 3D trigonometry. We have already done the concept of angle of elevation and angle of depression. If we talk about the angle of elevation of C from B, so that means this is the angle of elevation. And if I draw a horizontal over here, which is parallel with this, if this is theta, this is theta. This is angle of elevation of B, angle of depression of B from C. So therefore, this angle is the answer. Now let's look at some questions. Let's look at the first one. The question says, the diagram shows A, B, C, and D, the four corners of a horizontal rectangular field ABCD. So this is A, this is B, this is C, this is D. Calculate the length of DC. Now DC is this one, and the length of DC is given as AC is 110. And in order to find DC, I have to focus on this. So let me draw some lines. So first of all, this is DC over here. And we have the other length, which is this one, 110, that's given over here. And it's a 90-degree angle. So therefore, let me focus on this right angle triangle. So therefore, this angle is with the ground. Ignore 17 degrees, that is something else. So if I focus on this, this is 43. This DC is the adjacent of 43. So therefore, I'll apply cosine. 110 is opposite of 90. So therefore, the very first thing that we need to do is that cosine of 43 degrees, that equals to DC, the blue line, divided by 110. In other words, if I make DC the subject, that is 110 multiplying with cos of 43 degrees, and then I'll use a calculator. I'll get this answer. Let me get it first. So therefore, this is cosine of 43. So 43 degrees and then a cosine, and multiplying with 110. This comes out to be 80.45. So this is 80.45. This is in meters. That is the unit. Yeah. And therefore, this is 80.5 meters. And this is correct to three significant figures. So always remember the level of accuracy. That is non-exact answers in which approximation is necessary. They should be given finally to three significant figures. And there is an exception. That exception is angle in degrees. And in O-level maths, we only work with degrees. This should be given correct to 1 decimal place. So therefore, we should work in 4SF. We should work in 2dp in the case of angle. Now it says TC represents a vertical tree. So now let me mark this vertical tree. That's right over here. Now TC represents a vertical tree. The angle of elevation of T from A is 17 degrees. Now let me focus on this triangle that's right over here. And if it becomes too confusing, it's better idea. It's a good idea to draw a separate one. So this is A, this is T, this is C. So let me draw this part separately. So I'll choose this color. And I'll choose a green color over here. No, that's a purple one. And then let me choose another color, orange color right over here. So therefore, this is this orange color over here. So what do I have? I have this as 17 degrees. And then this is A and T and C. So this is A, this is C, this is 110 meters, and this is T. So they are asking us the height of the tree. So the TC represents a vertical tree. So height of the tree is TC. So therefore, tangent of 17 degrees, this is B part 1. Tangent of 17 degrees is equals to TC divided by 110. Make a habit of first making the subject, that is 110. tangent of 17 degrees. Then use the calculator altogether. You don't have to show tan 17 separately. So I'm writing in my calculator 17 and pressing the tan button and multiplying with 110. I'm using my mobile phone calculator. So this is 33.63 meters. Again, rounded off 33.6 meters, correct to 3 significant figures. So that should be the habit. And then it's asking for angle of elevation of T from D. So angle of elevation of T from D. So now I have to use this particular triangle. So let me label this one, and this, and this, and this. So now I have TC. Now I have DC. This is DC. We will use the unrounded value, and we will find this particular angle theta. So DTC, let me draw this. So therefore, this goes like this. And then we have the tree over here. And then this thing over here. And then we have, which one? We have DC in blue. So this DC is in blue color. And this is D, and this is T, and this is C. Use the unrounded value, 33.63. Use the unrounded value, 80.45. This is 90 degree. This is 90 degree because it's vertical. And I'm interested in this angle theta. So therefore, tangent of theta is 33.63. 33.63 divided by 80.45. So let me divide 33.63 divided by 80.45. And then shift and then tan. And this comes out to be 22.67 degrees, 69 degrees. Therefore, theta is 22.7 degrees, correct to 1 decimal place. So that is how this question is done. So now just write, just write on the WhatsApp group if this is all clear, all good. I've just drawn the figure sideways, I mean another aspect, so that it looks all good. Now this question over here, I'm confident that you people can solve it all by yourself. So let me pause the recording and give you a chance to try this out. Now in this question, it's the same type of question. Let's see. The diagram shows two horizontal triangular fields, ABC and ACD. So ABC is one of them and ACD is the other one, which are surrounded by hedges. It is given that DAB is a straight line. So DAB is a straight line. And then the measurements are given, 65 meters, 60 degrees, 72 degrees, and so on. Calculate the length of the hedge BC. So in order to find BC, what do we need? We need to label things properly. So we have this angle, and then we have this side. And then we have this side, actually this length, and then we have this particular angle. So therefore, we can apply sine rule. So we will write CB or BC divided by sine of 60 degrees is equals to 65 divided by sine of 72 degrees. Make BC the subject. That is 65 sine 60 degrees divided by sine of 72 degrees. And let me show you the working over here. And this is the answer, 59.2. That's the first part. The second part, the hedge AD has a length of 84. So AD is over here. That has a length of 84. Calculate the area of the field ACD. So now let me focus on this triangle. That's the green line over here. And then we have, let me draw it completely like this. And then we have a purple line over here. And then we have the blue line already is there. That's the blue one. And this angle is 60 degrees. So therefore, this angle is 120 degrees. This is 84. This is 65. Two sides included angle. So therefore, let's find the third side, which is DC. That is for DC and the area. So area is half AB sine C, that is 84. This is 84 into 65 into sine of 120 degrees. That you will get the area. What about the length of the edge CD? That is cosine rule. CD square is equals to 84 square plus 65 square minus 2 into 84 into 65 into cosine of 120 degrees. Remember, cosine of an obtuse angle is negative. There is this negative over here. It will become positive. Let me again show you the working. That's half AB sine C. 65 square, 84 square, they have written a plus minus. Correct formula, simplification and square root taken. Definitely it's a positive value. No, we won't use 60 degrees. We will use cosine of 120 degrees. I don't know why they give us an option. It's so straightforward. And therefore, you get this answer as this. Now let's talk about this part. A vertical tree is growing at C. The angle of elevation of the top of the tree from A is 14 degrees. So now we are talking about this thing. Let me draw some lines to illustrate this. So now this orange one is the tree. No, let me choose the marker. The orange one is the tree that goes like this. And this bluish one, this thing, this is too sharp. This one is like this. So the tree is there. A vertical tree is growing at C. Angle of elevation is 14 degrees. Calculate the height of the tree. So let me label this point as T. So therefore, we have TC. CA is 65 and this angle is 14 degrees. So TCA, let me make this triangle. So therefore, we have this thing like this. And we have the orange tree. And then we have this blue line over here. So this is T. And this is C. And this is A. And this is 14 degrees. And this is 65 meters. Calculate the height of the tree. Height of the tree is TC. So tangent of 14 degrees is TC divided by 65. So make TC the subject. That is 65 tangent of 14 degrees. And what is the answer? 65 tangent 14, that is 16.2 meters. That is 16.2 meters. Last one. It says a boy has climbed exactly halfway up the tree. Calculate the angle of depression of D when viewed by the boy. Angle of depression of D. Where is D? It's over here. So now we have the purple base. We have half the orange tree. And then this is the triangle that we are making. So we have DC, we have half the way. So let me draw another triangle. That is the purple line. And the orange tree is half the height. And we are interested in finding this angle of elevation over here. So if I use the rounded off value, which is this thing, I'll just half it. So this is 8.1 meter. Let me label this length as W. This is still C. And how much is this? DC, I think we calculated it. We did not as such. We just have to use this value. That is for DC. That is 129 meter. So this is 129 meter. This is 8.1 meter. This is 129 meter. This angle is beta. So therefore, tangent of beta is 8.1 divided by 129. Beta is tan inverse of 8.1 divided by 129. And let's find the value of beta. That's right over here. So this is the values from above. This comes out to be a very small angle, which is 3.6 degrees. So this is given correct to 1 decimal place. So I hope it's all good, all clear. Now, this question is from a recent past paper, I think 2021 or 2022, something like that. Let me send you these two images so you can try this one out also. So it's just a little bit of practice that we need to do. So this one, and just sending you over the two images. And I'll just stop the recording in a short while. Okay, so this is there. and the recording is stopped. Now, this question is from recent past paper. A box is made. A 3D object is there. It's a cuboid. Then there are some dotted lines like this. Some dotted lines also at the back. The diagram shows the cuboid. TW is 15. That's this one. WV is 10. WV is 10. RV is 8. The height is 8. These are the three measurements of it. Show that TR is 19.7. Now I need to find TR. Now, first of all, let me mark the different lengths. This is like 15. This is like WV. Let me first draw this green line at the bottom. So now these are 3 points on the ground. So let me draw it on the sidelines again. So that's like this. And then it's a right angle triangle because it's a rectangular base at the bottom. And then the third line like this. Now, first of all, some people, they can ask this question, why it is drawn tilted. It is drawn tilted. Otherwise, you won't have a feel of a 3D shape. That is why this is still 90 degrees. So now, first of all, this is 90. This is 15. This is 10. This is T. This is W. This is V. So therefore, let me first, this is step number 1. This is step number 1. So therefore, TV square is equals to 15 square plus 10 square. That is 225 plus 100. Therefore, TV is square root of 325. Don't touch the calculator. I'm not saying use it. I'm saying don't touch the calculator because it's too premature. Just go with the flow and let's see how the working goes. What is step number 2? Now, step number 2 is, now I'll be focusing on the green base and I'll be focusing on RV. So let me focus on RV like this. And then let me draw this line that's right over here. So now my triangle is TRV. So let me draw it again. So this is like this. And then this green line is the base. And then the purple one, that is the height. Now, first of all, let me label it. This is T, this is V, and this is square root of 325. This is 90 again, and this is V and R, and this is 8, and we are interested in TR. Now, let's see how have I preserved the accuracy of the question. TR square is equals to square root of 325 square plus 8 square. That is 325 plus 64. So 325 plus 64, let me add it up and let me take the square root. 325 plus 64, that's 389. So therefore, TR is square root of 389. The answer is already given correct to 1 decimal place. So all I have to do is press the calculator button and I'm getting 19.72. That is 2 dp, and then round it off, which is 19.7, 1 dp. I'm pausing for Azan. So now the first part is done and dusted. All good, all clear. Now let's think that if I were to use the calculator at this stage, which I know that I have to use it for the second part, then I would be working with a lot of decimals over here and then squaring it again. So it's convenient to use the exact form and then get the final answer in decimals. Now, what's the next part? It says X is the midpoint of PQ. X is the midpoint of PQ. PQ is the same thing as this. Calculate TRX. So we are interested in TR and X, the angle. So this is like this. So I have to find this angle, okay? Now, first of all, I have TR. So let me first write TR. Again, I'll be using this exact value. So TR is given. That was the pinkish line. Okay. So first of all, let me focus on this thing. So TR is already known. Let me just draw this. And I'll draw it also over here. So this is TR. And what else is there? XR. So XR, I can draw it like this. So let me draw XR over here. So I will be needing XR like this. And then I have TX. So I'll be needing TX. So TX is something like this. Okay, just a small version of that. So this is TR and X. Now, first of all, there are two triangles that I need to focus on. That is, first, I need to focus on this triangle, which is this red line and this red line. This one and this one. So this is the first one, that is XPT. So this is X and this is P. And this green one is what we are looking for. That's like this. So again, it seems like Pythagoras theorem. This is X, this is P, this is T, this is 90. XP is half of 10, which is 5. Why is it? Because this whole thing is 5. This whole thing is 10. This is also 10. This is also 10. This is also 10. It's half of that. And we know that TP is this thing, which is 8. So TP, this is 5 meter. This is 8 meter. And therefore, let me calculate TX. So TX whole square, that is 8 square plus 5 square. This is 64. This is 25. That comes out to be 89. Therefore, TX is square root of 89. That's the first thing. So let's say this is step number 1. And then let me just erase this thing. I don't need it right now. This is step number 1. And let me focus on this. That is this thing over here and this thing over here, and then the blue line. So that is like this. And then this blue line. So this is XQR. This is X, this is Q, this is R. XQ is again 5 meter. QR is 15. And I'm interested in XR. So XR whole square, that is 5 square plus 15 square. This is meter. I don't need to write the units, so let's not make it confusing like this. And over here, I can remove it. Okay. So now 5 square is 25, 15 square is 225, that is 250. Therefore, XR is square root of 250. So this is step number 2. And this is for 5 marks. Just look at the marks. And the third one is now what we should be looking for. That is this green, this blue, and this pink. So this is this thing, this green that goes like this. It's green over here. And then there is this blue that goes like this. And then the third one is this pink. So therefore, this pink goes like this. Okay. So now let me label it. This is step number 3. So therefore, this is TX. TX is root 89. This is T. This is X. This is root 89. And then we have XR, which is root 250. And then we also have TR. TR over here is root 389. So this is root 389. And we are interested in which angle? We are interested in TRX. So we are interested in this angle. Let me label it theta. So let TRX be labeled with a symbol theta. So therefore, we have to use cosine rule because all 3 sides are given. So therefore, root 89 whole square, that is root 250 whole square. This is root 389 whole square minus 2 into root 250 into root 389 into cosine of theta. So now let me use a calculator. So therefore, this is 89 minus 250 minus 389. And this equals to I'll use a calculator over here. First of all, let me multiply 250 into 389. And let me take the square root. So this is, hold for a second, 250 into 389. I'm multiplying it out, then taking the square root, then multiplying with 2. That comes out to be negative 623.70 cosine of theta. And then we have 89 minus 250 minus 389. This comes out to be negative 550 over negative 623.70 is equals to cosine of theta. So let me divide. So 550 divided by 623.7, 623.7, this comes out to be 0.8818. So therefore cosine theta is 0.8818, and therefore shift and cosine, and this comes out to be 28.16135, actually 14. So therefore theta is 28.1 degree, correct to 1 decimal place. Now let's double check. The answer is not given over here, but it makes perfect sense. So now look at how many times this particular examiner has made use of Pythagoras theorem. 1, 2, 3, and 4. 4 times the examiner has made use of Pythagoras theorem, and once the cosine rule. Maybe the examiner is Pythagoras himself. So that is why he's making too much use of Pythagoras theorem. So that completes this question. Let me pause the recording and first look for some new question. Now let's look at this question. The question says the diagram shows a right angle triangle with dimensions given in centimeters. Show that. Very simple. It's an application of Pythagoras theorem. So we will write 3x plus 5 the whole thing square equals to 8 square plus 2x the whole thing square. A word of caution, that is, always use brackets. Because what people can do in this particular question is that in a hurry, they can write 2x square rather than this becoming in reality 4x square. And over here, still people use a bracket. I'm more interested in people using it over here. So therefore, this is 9x square plus 30x plus 25 equals to 64 plus 4x square. So 9 minus 4, that is 5x square. 30x remains as it is. The difference between 25 and 64 is negative 39 equals to 0. Solve the equations, give your answer correct to 2 decimal places. That's Pythagoras theorem. X is equals to minus b plus minus square root b square minus 4ac, the whole thing divided by 2a. So therefore, this is minus 30 plus minus b square, which is 30 square minus 4 into 5 into negative 39. So again, be careful because this negative and this becomes a positive. So now we have this thing. Let me just highlight over here. That is this negative over here. There is this negative over here. That will become positive. So 4 into 5 is 20, and 20 into 39, that is 780, and 780 plus 900, that is 1680. So this is negative 30 plus minus square root of 1680 divided by 10. And then we know how to do the working. So it's either or, minus 30 plus square root 1680 divided by 10, minus 30 minus square root of 1680 divided by 10. We need the answer to 2 decimal places. Therefore, work in 3 decimal places. So that's the thing. What about the area of the triangle? That's half into base into height, half into 8 into 2x. So area is half into 8 into 2x. That comes out to be 16, that is 8x. And we'll plug in the value of x and we will get this answer. I'll just open the mark scheme very soon. Now the diagram shows a different right angle triangle. The length of the hypotenuse is 12. Calculate the shortest distance. Now that's the whole purpose of this question. I have made you solve this question because of this. Shortest distance from A to BC. So the shortest distance is always the perpendicular distance. That's the first thing that we all are aware of. So now let me write this. The shortest distance is the perpendicular distance from A to BC. And they're interested in this. So now what needs to be done? The length of the hypotenuse is 12. So this whole thing, this red line is the hypotenuse. Okay. So now let me mark this thing 12 centimeter over here. And we are interested in the green line. Now, what can be done? What we can do is that, how many marks is there? 4 marks. So can we first use trigonometry and find AB? Yes, we can. So let's use trigonometry. And we can say, let me focus on this. So there is this black marker, and then there is this blue marker. And then let me use this purple marker. Now, if we focus on the big triangle, that is this. Opposite to 90 is 12. Opposite to 35 is this. That is AB. So step number 1. That is, let's use sine of 35 degrees. This equals to AB divided by 12. Let's make AB the subject. That is 12 sine 35. I can leave it as it is. I'll use the calculator later. Now, if I focus on this thing, this is 90 degree. And I have AB. I need to find this height. So this angle over here is 55 degrees. Can I use 55 degrees to find H? The answer is yes. I can say that sine of 55 is H divided by AB. So for this 90 degree, this is the hypotenuse. So step 1 is basically using the big triangle, that's ABC. That is triangle ABC. For this one, I'm using this triangle. Let me draw it over here. That is the green one. And that's partially the red one. And then I'm interested in this purple one. That's this thing. Hold for a second. So that's how this is drawn. Now, this is step number 2. And now I'm using the triangle. This is A and ABC. Let me call this thing as D. So this is D and this is B. This is 55 degrees. 90 minus 35 is 55. This is H. And this thing is 12 sine 35. Whatever the decimal value is. So now if I use sine again, I'll say sine of 55 equals to H divided by 12 sine 55. You can even use the decimal value. Therefore, H is, this is not 55, this is 35. Let me just correct myself. Yeah, this is 35. So H is equals to 12 sine 35 multiplying with sine of 55. So let me use this value first, 12 sine 35. So first of all, 35 and then sine and then 12. This comes out to be 6.883, which can be written as 6.88. And over here, instead of this, let me write this value. Otherwise, you will be a bit confused. So now this is an rounded value, 6.883. This is 6.883. This is 6.883 sine of 55. So 55 sine multiplying with 6.883. This comes out to be 5.638. This is 5.638, which can be written as 5.64, correct to 3 significant figures. This is also 3 significant figures because that's the official this thing. So that's the shortest distance. Now let me write this thing as method number 1. So this is not the only method. This is method number 1 that I've employed for this particular question. Now let me add a page. Let me copy this. And let me try out another method. See whichever one you find to be easier. Now over here, again, the first step is the same between the two. So that is this thing that is about the hypotenuse. So blue, purple, and this red. So let me first write this. This is red, and this is blue, and this is purple. Now, first of all, the first step is exactly the same. That is over here. Triangle ABC, I'm calculating AB, that is 6.88. So method 1, that is AB, is 6.883. This is just like before. Now, if I have this is 12 and this is 6.883, and if I find the area, actually I could have found BC first. Hold for a second. So let me find BC in this. So let me use cosine. Cosine of 35 degrees, that equals to CA divided by 12. So CA is 12 cosine 35, and then I'll tell you the reason what I've done. So 35 cosine multiplying with 12, this comes out to be 9.830. So CA is 9.830. Now, this is step 1. This is method 1, method 2, step 1. So this is method 2, and this is step 1. Okay, now what is step 2? Step 2 is area of triangle. The big triangle, that is ABC, that's half AB sine C. That is half, and this is 12, and 9.830 into sine of 35 degrees. So let me write 35, and then sine, and then 0.5, and then 12, and then what else is there? 9.83. This comes out to be 33.83. This is 33.83, and the unit is centimeter square. This is centimeter, this is centimeter square. And now what I can do is that I can involve step 3. The same area can be obtained if I have this green thing, not this thick, this green thing as the height. So now this is the height. So this is the height, and now this is the base. So this should give me the same area. So half into h into 12 equals to 33.83. So divided by 6, and this answer comes out to be, h comes out to be 5.638. I think it's the exact same thing over here. 5.638 or 5.64 centimeter, correct to 3 significant figure. So there is this method of using areas. There is this method of using trigonometry. So these are the 2 different ways of solving this question. And that completes our lecture of trigonometry. So trigonometry is all done and dusted.